Alright, you guys, today we are going to learn about linear equations, or also commonly known as linear functions. And a linear equation is any equation in two variables whose graph is a straight line. And a straight line is going to be very important when dealing with linear equations. Here are some examples of linear equations. Y is equal to 3x plus 2, and this is called standard form of the linear equation. You also sometimes see it written as f of x equals 3x plus 2. This is function notation, but they both equal the same, mean the same thing. So what a linear equation looks like on a graph is a straight line. So if you notice that it continuously goes up and it continuously goes down, there's no ending point with a linear equation. Here would be another example of a linear equation. So the arrows mean that it's continuous, it never stops. So a non-example written in standard form is y is equal to 3x squared plus 2. If you notice that there's an exponent here, so that's not a linear equation. So what a non-linear equation would look like on a graph would be something like this. This is a parabola, or anything zigzag. That would not be a linear equation. Alright, so what we're going to do is we are going to learn how to graph linear equations. And here are your steps that you can write it down. And you can always pause the video so that you can make sure you get all the information written down. So the first thing we're going to do to create a linear equation on a graph is to create a table of ordered pairs, our x and our y. And then what we're going to do is we're going to plug our x values in to get our y values. You can choose any x values that you want. And I always pick some negative values and some positive values. And then you're going to graph the ordered pairs. So the first one that we are going to graph is the one in our note sheet. Y is equal to 3x plus 2. So you're going to need your graph paper. And I started creating a table here. Okay. So we learned in class that a function table, you need a function rule. So we're going to use the function y is equal to 3x plus 2. So I'm just going to make up some x points, negative 2, 0, 1, and 2. You notice I always choose 0. That tells you a lot of information when we're looking at graphs and reading them. So you always want to pick 0 as one of your points. Alright, so we're going to plug in negative 2 here in our x, and then once we do this, it's going to equal our y value. So 3 times negative 2 is negative 6, negative 6 plus 2 is negative 4. Anything times 0 is 0, and plus 2 is 2. 3 times 1 is 1, plus 2 is 5. And 3 times 2 is 6, and 6 plus 2 is 8. So here I have my function table, and all they are is ordered pairs. So these ordered pairs, since I plugged them into my equation, are guaranteed to be on this line. So that's how we create our line. So I'm going to go in and graph these. Negative 2, negative 4, 0, 2, 1, 5, and 2, 8. And having a ruler would probably help you out a lot, but I don't have one, so I'm just going to sketch it. And then you just connect the dots. And like I said, you can choose any points. I could have chosen some x values down here. And don't forget, these arrows mean that this line goes on and on. So these are not the only points on this linear equation, they're just some of them. So one way you can tell if you were right is to determine if this was a straight line. And this is a straight line, so we have a good idea that these points are on that line. The next equation that we're going to graph is y is equal to 2x. So I'm going to make my ordered pairs. And this time I'm going to pick negative 1, 0, 1, and 2. And again, they can be any points. You're always going to choose 0, and you want to choose some on the negative and some on the positive. So I'm going to plug all of my x values in here. So 2 times negative 1 is negative 2. Anything times 0 is 0. 2 times 1 is 2, and 2 times 2 is 4. Go ahead and graph these. And then you just connect your dots. Okay, the next one we're going to graph is y is equal to 1/2 x plus 1. And I'm going to use the points -2, 0, and 2. Alright, so you plug in 2 to your x, and 1/2 times -2 is -1. -1 plus 1 is 0. Anything times 0 is 0, and 0 plus 1 is 1. 2 times 1/2 is 1, 1 plus 1 is 2. So you plot your points, -2, walk to -2, fly to 0, walk to 0, fly to 1, and walk to 2, fly to 2. And you can choose at least 3 points. So at least 3 points will give you an idea of how the line, the linear equation looks. So 3 to 5 points will give you a good idea. Alright, so here's a funky one. And we're going to do the funky ones on the same graph because I'm running out of graph paper. The first one is y is equal to 4. So you notice I don't have two variables here, but this graph tells you a lot. It says that wherever you go on your x-coordinate, y is always going to equal 4. So if you create your table, y is always going to equal 4 no matter what points you create. So if I did -1, 0, and 1, y is always equal to 4. So what this also tells you is that y is going to touch the y-axis, if I can spell, at 4. So here's the y-axis, and you're going to go to 4, and it's going to be a straight line, a horizontal line, because y is always equal to 4. No matter what your x value is, y is equal to 4. -1, 4, 0, 4, 1, 4, 2, 4, 3, 4, etc. So this is y is equal to 4. And the last one we're going to do is x is equal to 5. So here I had y is equal to 4, and my straight line was on the y-axis. So you could assume that on this one, your straight line is going to be vertically wherever x is equal to 5. So here's my table. So on this time, for this example, x is always equal to 5. So you just put 5s here. And no matter what it is, whatever your y is, x is always 5. So you go to your x-axis, and you go to 5, and so it would be a vertical line. So this is x is equal to 5. So that is how you graph linear equations. Again, all you do is take a table of ordered pairs, you create your x values, and input them into your function rule to get your y values out.